All right, now here we go with our quick deep dive into condensing, undoing all the stuff we just learned about. So basically we just Fred Astaire, now we're gonna Ginger Rogers, we're gonna do it all backwards and in heels. All right, so here we have log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2. Notice they're all the same log bases. That's important. You can't technically condense unless they're the same. So if you're ever asking yourself, which log base should I use? Pause, rewind. You got a mistake somewhere. In math, we typically don't see problems with different log bases in them. So you should never be asking yourself that. All right, but log base 3 of 5 plus log base 3 of 8. I know what that plus between two logs means. It means these two right here could be rewritten as the log of 5 times 8. And then I know what that minus sign means. That means a fraction. So 5 times 8 divided by 2. 5 times 8 is 40, divided by 2 is 20. So this is log base 3 of 20. All right. Now we have another one. Now this one has a lot more going on, but I say these are all log base 10, the invisible base. I say we just throw them all together at once. So this will be the log of 3 on top. Then it's minus log of 4. So the 4 goes on the bottom. Plus the log of 5. So that 5 is going to get multiplied on top. Minus the log of 6. So the 6 goes on the bottom. Multiplication between those two. And then log of 15/24. And now let's do it with it even crazier. We can do it. So log base 2 of x squared. So like my gut instinct is, ooh, move the 2 down. And then I'm like, wait. No, we're condensing. Don't move the power down. Leave it where it is. Plus 1/2. This power needs to come up. Minus 3. Now we can move this as a -3, or we can leave the negative and just move the 3 and then end up writing it on the bottom. Either way is correct. Typically, when we finish these compressions, we want to write things without negative exponents. So you can do it either way that makes sense to you. Just at the end of the day, eventually you have to move it down to the bottom. All right, so first step, not changing too much, plus log base 2 of x minus 1 to the 1/2 power. And then I'm going to go ahead and leave the minus. Log base 2 of x plus 3 squared cubed. So squared and then cubed, 2 times 3. This will be x plus 3 to the 6th. All right, now 1 log. Log base 2, big giant fraction. So we have the x squared is on top. The x minus 1 to the 1/2, which you could write as the square root of x minus 1, but meh. And honestly, for calculus, you'd rather have the 1/2 power. And then on the bottom, x plus 3 to the 6th. Do not multiply that out. I know you guys can, don't waste your time. That is perfectly acceptable as an answer. We have done as asked. They said condense. That's 1 log, done. All right, now we do it again with a, well, isn't that a sneaky little such and such? That is 1 over x as the coefficient in front of that log. All right, well, power's up. So this one will be log of x squared. I'm going to leave the minus and just write this as the log of x plus 5 to the fourth plus the log of 3x plus 5 to the 1 over x power. And if you want to put some parentheses around the 1 over x, that's fine. Like, this is a very weird thing. I've really only seen it like in this situation when we're just playing around with what are the crazy things we can do with compressions and expansions. Yeah, no real logic to it. Just, look, it'll do this. All right, so the x squared log didn't have a minus in front, so it will be on top of the fraction. The x plus 5 to the fourth does have a minus in front, so that will go on the bottom, still with a positive 4. And then the 3x plus 5 to the crazy 1 over x power. All is one log, done. What the heck they want to do with that 1 over x and all that? Like, seriously, we don't do 1 over x's power. It's weird. It's bizarre. Like, let me rephrase. We don't have x in the base and then have x in the power. Unless you're doing some really crazy high-level math. Now, our last thing is, well, what do I do when I actually want to calculate one of these ugly numbers? Because when you look on your calculator, it's only got 2 logs. It's got log with the invisible base 10, and it's got ln, which is log base e. This will let you convert any other log into a quotient of those two. So log base b of m can be broken down into log base, a new number, n of m, divided by log base n of b. So in calculus, you're going to learn e to the x is like fantastic and super lazy. So we're going to spend a lot of time actually using change of base to do like natural log instead of log base 2 or log base 3. And the change of base formula is what allows you to do that. So I'm just going to kind of box the natural log one to just be like, that's the one you want to get the most familiar with. So here we have log base 5 of 3. We're being asked to change this to a quotient of natural logarithms. So log base 5 of 3 equals, well, they said natural log, sorry. So ln, big number, like as in 3 is big, 5 is small because it's written as a subscript, not larger. And then ln of the base number, but now it's on the line. And that's it. So if we're looking at some crazy log base like this, I can change it into natural logs, I can change it into log base 10s. And then those are things that are on my calculator, so I can actually crunch them up and do what I need to. That's all we got for log properties. All right. Last set of videos will be on log equations. I'll see you then.